Hello everyone, this is Professor Jeff Wilkerson at Luther College, bringing you what to look for in the night sky for the week of August 2nd, 2021. So we've rolled over to August, and for this week we're going to return to Scorpius that we looked at a few weeks ago. And we're going to use Scorpius to guide us to some globular star clusters. And we'll talk about globular star clusters a little bit more. We mentioned we looked for a globular star cluster a few weeks ago in Hercules as well. You can go back and look at those videos. The bright star in Scorpius that you really want to lock in and make sure you can find is Antares. Antares is this bright orange star. Right now, for me, if I go out and I look due south at about 9 o'clock, I'll see Antares low on the horizon. So for those of you who are at mid-northern latitudes like myself, remember that Scorpius doesn't get very high above the southern horizon. You got to look pretty far south. Antares, because of all that atmosphere you're looking through, that makes Antares look even oranger, even redder than it would otherwise. So it's a really bright orange star down there, and it's one of the first stars I see when I look south. In fact, I use this as my alignment star every night when I start taking data. I point the telescope at Antares, and I say, you're looking at Antares, and then my telescope knows where to go, where to find the cluster that we want to look at, which is not too far that direction on this drawing. So when you see Scorpius, what you'll see is Antares first, as it starts to get dark about 9 o'clock, and then you'll see the three stars out in front here start to appear after that. So that's the bright pattern that you'll see first in Scorpius. And I've drawn that up here. I reproduced it down here because this got pretty busy pretty fast. Those are the three bright stars out front, and there's Antares right there. Antares is a first magnitude star, and remember that stars, the magnitude system counts backward, and it's so brighter is a lower number, and every step in magnitude is a multiplicative factor of 2.5 or so. And so Antares is a first magnitude star. That's a pretty bright star. There aren't a lot of stars in the sky that are brighter than that. And these three stars out in here, they range a little bit, but they're somewhere around 2.5 magnitudes. So about 1.5 magnitudes fainter than Antares. The beta, delta, and pi are these stars. Antares being the brightest star by far in Scorpius is the alpha star in Scorpius. Now, what I've marked on there are a couple of other stars. Within 2 degrees of Antares here are Sigma and Tau, and these are sort of third magnitude stars, so noticeably fainter than these three stars. These are fourth magnitude stars, Nu and Rho right here. But if we go back to Sigma and Tau lie on either side of Antares and are only about 2 degrees away. And so remember that you hold your fist up at arm's length. We've done this a lot here lately. You hold your fist up at arm's length. That's about 10 degrees. That you're seeing that angle. You hold your finger out at arm's length, and that's about 1 degree is that angle that you see. So that's a couple of finger widths to either side of Antares. You'll see Sigma and Tau, these relatively faint third magnitude stars. And in between Sigma and Antares, and just below there, is M4. Very, very big, bright, sprawling globular star cluster. So it's one of the better globular star clusters in the sky. Probably you can see it with a good pair of binoculars. And if you have a small telescope, it's one of the easier ones to find due to its proximity to Antares. And you can draw a line from Antares to Sigma and move over a little less than halfway or about halfway and drop down. And you'll find it. And you can, some low power eyepieces, which is a great way to observe these things, is with low power eyepieces, will show M4 and Antares in the same field of view. So that's your target. Learn Antares, learn beta, delta, and pi, the three stars out here. See if you can find Sigma and Tau stars in Scorpius, and then locate M4 down here. Now, up this direction from M4 is M80, and the separation from Sigma to Nu up here. Remember, Nu is about a fourth magnitude star. So we've got a third magnitude star to a fourth magnitude star, another fourth magnitude star down here that form this sort of arc out in front of Antares, leading the way for Scorpius. So about maybe a third of the way up, right on the line from Sigma to Nu, and about a third of the way up is M80. M80 is a more compact globular star cluster. Another globular star cluster, more compact than M4 is. and a good target thus in a telescope or binoculars. It'll be a smaller dot, but a brighter dot often. So even though M4 is brighter, that light is spread out over bigger. It's one of the most sprawling of the globular clusters. So there's more total light there. There's a lot of total light there, but that total light is spread out, making it a little bit harder to see. It wants to merge into the background more. And so M80 looks like a tighter, brighter dot of light. And so it's a little bit easier to find, maybe, on this line from sigma to nu. So go out and look for that too, binoculars or telescope, and get familiar with these stars around here. Let's take just a moment and talk about globular star clusters, if we may. Just say, here's the side view of the galaxy. Let's make the bulge of the galaxy a little bigger. We're out here someplace. The globular star clusters, well, this is the disk of the galaxy, that's the bulge of the galaxy, and we're out, 2/3 of the way, a little more than that, 28,000 light years, 26,000 light years from the center here. And if we look back this direction, we're looking at the direction of Sagittarius, which is right back here on the tail of Scorpius. The globular star clusters live in a halo around the center like this. So this is the direction we want to look. Mid to late summer is the time to do it. Of all the globular star clusters known in the Milky Way, all of them that the Milky Way hosts in a halo around the center, half of them exist in the three constellations of Sagittarius, Scorpius, and Ophiuchus. Sagittarius sits behind Scorpius. Ophiuchus sits here above Scorpius. There are 88 constellations in the sky. So if the globular clusters were spread across the sky, you would expect to have to look at about 44 constellations to find half of them. But instead, you only have to look at 3 to find half of them, looking over this direction. So this is globular cluster zone. This is where we're looking. Globular clusters are uniformly old. The open star clusters that we looked at in Scorpius a few weeks ago can have varying ages. The new stars are formed in the disks of spiral galaxies right here. And that's where open star clusters are right in the disk of the spiral galaxy. And so you can look in the disk of the spiral galaxy, you can see new star clusters, old star clusters, star clusters in between. Those are open star clusters. The globular star clusters were formed in one single burst a long time ago. And so they're uniformly old clusters, and they have about 500,000 stars in them typically. So several 100,000 stars is what you would find in these globular star clusters when you're looking at M4 and M80 right here. We'll leave you with a chance to go find a couple of more. So if you find M80 and you move back above Antares, all the way back over here, about 11 degrees, so more or less a fist width at arm length like that, and more or less move straight to the east. From M80 across here, you'll come to M19, another globular star cluster. And if you do the same thing with M4, about 9 degrees, so a couple of degrees shorter, but still about a fist width at arm's length, and you move back across here, you'll run into M62. These are both fine globular clusters, relatively easy to see. Look for them in your binoculars, look for them in your small telescope, and see if you can find these clusters. They're a little bit harder to find because you got to move further along this direction. And you don't have the big bright star Antares or the straight line from sigma to nu up here. And so you don't have as many stars to find. We could find some other stars that would help us locate these, and maybe we will just for the fun of it in a week or two. But this is what we're talking about right here, is this region of the sky where you can find sort of a quadrilateral. So you're looking at a rectangle of open star clusters, more or less. It's really not quite a rectangle. So these two line up. And then you got this side laid out just a little bit because of that 9 degrees and 11 degrees. So it's more of a quadrilateral of globular star clusters for you to find. So go find Antares, big bright orange star. Find the 3 stars that make up the front of Scorpius out ahead of Antares, Beta, Delta, and Pi. Then find your fainter stars, Nu, Rho, Sigma, and Tau. Use all of those stars to find as many of these globular clusters as you can. Think about where the globular clusters are in space. They first helped us map the distance to the center of the galaxy. Understanding that all the globular clusters were located in a halo around the center of the galaxy, we were able to figure out that if we could find the average distance to the globular clusters, we might find the average distance to the actual distance to the center of the galaxy. And so this helps us think about mapping the galaxy out there. Good luck with it, everybody. Hope you have some clear skies and some good observing.